Hello, welcome to APL 360. My name is Jamie. This video is part of my series on the APL 360 programming language. This episode is Basics 3. In the previous episode, we started defining functions. We ended with the definition of the factorial function. And in this episode, we're going to continue working through the Appendix A of the APL 360 User's Manual. The next function that we're going to define is for greatest common divisor. Del G gets M GCD N, G gets N, M gets M mod N, branch to 4 times M not equal 0. We're going to make a correction of line 1. We'll put 1 in square brackets, and then the new complete definition for line 1, G gets M. We'll resume with line 4 by putting 4 in the square brackets and then typing what we want for line 4, which is N gets G. We'll display line 1 with left bracket 1 quad right square bracket. We'll display the entire function with left square bracket quad right. Let me redo that. Left square bracket quad right square bracket. There we see the complete function definition. The del at the bottom there is the close of the display, but it's not the close of the definition. So we can begin more code here on line 5, and we'll put in a branch to 1 for line 5. And I see that I made a mistake. I put in a left arrow instead of a right arrow. So I'm going to go back and then do a line feed, and then do a right arrow 1. Now I'm going to close the definition with the del on a line by itself. We'll use the function to find the greatest common divisor of 36 and 44. So do 36 GCD 44, and that's equal to 4. We're going to reopen the definition using del followed by the function name by itself. We're going to insert a line in between lines 4 and 5. So we essentially are using an interpolation here. We'll do a left square bracket and put in a new line number 4.1, right square bracket, and then the code for this line will be M comma N. This will display the values of M and N. We will display the entire function. So now you can see line 4 followed by line 4.1 followed by line 5. We'll close the definition. We'll do the calculation again, 36 GCD 44. And now we can see the iterations of the function and the values of M and N being displayed for each iteration. We'll reopen, display, and close GCD all at once. So we will do a del GCD, and then left square bracket, quad right square bracket, and then a closing del. You'll see that in the previous definition, line number 4.1 has been renumbered to line 5, and that happened when we closed the previous definition. While we were still working in it previously, it was still line 4.1, but once it was closed, those line numbers were renumbered. We're going to reopen the definition and then delete line 5. So we'll do del GCD. We'll put in the line number 5. And then to delete an entire line, we just do a line feed on that line number. So I'll do a Shift X and press enter. And then we can redisplay the function with left square bracket, quad right square bracket. And so we'll see that line 5 is now deleted. We'll go ahead and close the definition with a del on a line by itself. So the next function will be just a kind of a throwaway function that doesn't really mean anything, but will show another way of editing a line. So this function will start with del z gets abc x, and we'll start the definition with z gets left parenthesis 33 times q plus left parenthesis r times 5 right parenthesis minus 6. Now we'll initiate an edit of this line by doing a left square bracket, editing line number 1, but instead of closing the bracket here and typing in a complete new line for line 1, we're going to put in a quad followed by a 9, and I needed a right square bracket there, not a parenthesis. So I'll back up and do a line feed and a right bracket. So this puts us into an edit mode where a slash will represent a delete, and a digit that we type will represent a number of spaces to insert. We're going to delete this first 3, and then I'm going to move over here to the plus and insert 1 space, and then delete the R, and then insert a space after that. I'll press enter. So now the deletes and the spaces have been carried out, and we're now editing this line. The things that we want to keep, we will need to space over. So at this spot, we're going to close the right parenthesis, and then I'm going to press the space bar to move forward to this blank space that was here. Looks like the other characters have been erased, but they're not. APL is keeping those the same, but they've just been wiped out on the terminal, but they're still there. And we're replacing the R with a T. And then press enter. We can redisplay this with left square bracket, quad right square bracket. And so there you see the complete form of line 1 that looks just fine. And then we'll close this definition. So we have to remember that APL 360 was implemented to run with a TTY display where you had basically a typewriter. And so all of our editing modes are line edits, and so that's why we had that kind of special mode there to do the deletes and insertions. So we'll close that definition. Now we still have factorial defined previously. We can erase functions from our current workspace by doing a right parenthesis erase and then the name of the function. So we'll erase factorial, and then we can try to use it again, and we'll get a syntax error here because function fact no longer exists. Our next function will be for binomial coefficients, and we're going to put in an erroneous function, and then we're going to show suspending the execution being suspended, and then we're going to resume execution, make some changes, resume, and so on. So essentially building up kind of our own trace of how this function's operating, but as we make mistakes, we can go in and make fixes and then continue the calculation without restarting the entire calculation again. So this new function will be defined as del z gets bin in. We'll put in a label LA colon z gets left parenthesis z comma 0 right parenthesis plus 0 comma z. And then we'll do a branch to LA times n greater than or equal to row z, and then we'll close the definition on this line. So we don't need to put the closing del on a line all of its own. We can just put it at the end of the last line of code. Now we're out of the function editor. We're going to use the function bin3, and we get a value error. So it's telling us that essentially no value was assigned to z when we're referencing it here. So we're going to we're essentially in suspended execution. So we will assign z a value. Z gets 1. And then to resume execution, we'll use a branch to line 1. And then we see that we get the binomial coefficients of order 3 when we do that. So we'll do this again. We'll do bin4. So again, we get the same error because that local variable z that we had defined previously as being 1 does not retain its value. So this time we will insert a new line as a line number 0.1. So we'll do this all on one piece of code. We'll do del bin, and then do the line insert here on the same line. We'll do left bracket, 0.1, right bracket, and then do the assignment to z as we did previously, where we saw that that made the code work. But here we're adding it as a line to the code. Z gets 1, and then we'll close the definition. So this is a quick way of just getting into the function definition, adding a new line, and closing it all within one line of code. Now we'll display the state indicator. The state indicator is kind of an internal flag that shows us what state the kind of previous function execution was in. So it shows us that we essentially stopped on line 1. So we're going to resume the execution. We'll do a branch to 1. And this code gives us the correct answer. We'll display the revised function. We'll do this all in one line. Del bin, and then left square bracket, quad right square bracket, and then closing del. And there we see the complete definition, and our previous line 0.1 was renumbered here, and it became the new line 1, and the other line numbers were shifted. We see the advantage here of using text labels instead of just using the branch to a particular line number that's hard-coded, because we may need to insert lines so that the previous lines get renumbered. This next line of code is going to tell APL to stop the execution at line 2. So we'll do S a delta, and then bin gets 2. And then we'll run this, and that's essentially setting a stop point in the code. We'll execute bin 3 and assign the value to Q. Q gets bin 3. And we see that we have stopped on line 2. We will display the current value of Z. Z is 1. We'll resume execution with jump or branch to 2. So the execution resumed, but we didn't clear the stop code, so it stops again. We can examine Z again if we wish. Okay, so we see Z now contains different values. We can resume again. We stop at line 2. We can branch to 0, which will terminate. 0 represents the header line, but any thing that branches to 0 is essentially jumping out of the function and terminating it. The next example is going to show input and output in function definition by writing a function to do a multiplication drill. So we will define mult drill. Takes a parameter in, and then there will be two local variables, y and x. So y gets question mark n. This will get in random integers. That's what the question mark used monadically here will do. And then we will print those random factors. I needed to go to the next line, so I'm going to back up and do a line feed and press enter. And then on this line, we will do y by itself to print those integers. We will get keyboard input. X gets quad by itself. And again, I typed the wrong character there. Let me backspace and do a line feed. Okay, I'm going to display what I have so far. Okay, again, I'm getting my fingers on the wrong keys in the keyboard here. Let's display what we have. Okay, so that looks good so far. On line 4, we will stop if the entry is the letter S. And so the way that we code that is a branch to 0 times iota x equals the character S. So we'll put that in single quotes. And the next line will repeat if the entry is the correct product. So the user is being prompted to figure out what the numbers being shown, what their product is, and if they get that correct, then we want to repeat and show them some more numbers so that they can keep going. If it's not correct, then we want to fall through to the next line and show them a message that will tell them to try the same calculation again. So on this line 5, to repeat what we've done previously, if they've entered this correctly, we will do a branch to iota x equals times slash y. So the slash here is an operator that is doing the multiplication between all of the numbers. And so this does the correct calculation, and then it's checking to see if x, which is the input number, is equal to that or not, and then doing a branch if it is. Otherwise, we will fall through to line 6, and we want to display the message wrong, try again. And then to facilitate that, we jump to 3, branch to 3, and then I'll close the definition. So we're going to do a multiplication drill for pairs in the range of 1 to 12. So the first problem we're presented is 2 times 10, and we're going to put in a wrong answer. So we're prompted with wrong, try again. We'll put in the correct answer. Now we're presented with a new problem, and we could continue practicing here if we wish, but we're going to stop the execution by putting in the character S for stop. The next example, we'll use quote quad, which is a character made up of 2 symbols, to allow character input. So we'll do del Z gets enter text. Line 1, Z gets quote quote. Line 2, D gets row Z. Line 3, Z gets Z comma quote quad. So I'm going to do a quad character. Then I'm going to backspace and do a quote, which is Shift L on top of it. Okay, so I don't see the combined character here. So I may have done those in the wrong order. Let me try that again. Backspace and do, sorry, I said Shift L. Shift L is the quad character. Shift K is the single quote. So I just put in the wrong character. Now, because I did 2 quads on top of each other, I'm not sure if this is going to work or not. We may end up with an error. I'll press enter, and then I'm going to redisplay the function, see if I see anything that looks out of place here. So it looks okay. We'll see when it runs if everything is okay. This is a pending keyboard entry. It's as if we're above when we wanted the user to input something, and we just used quad. For them to input the symbol S, they had to put quotes around it. Here, when we use quote quad, it's essentially doing the quotes automatically. And so when we enter in text, we don't have to put in the quotation marks ourselves. And so line 3 is appending their entry. And then we're going to branch to 2 if the length is increased. That means if the entry is not empty. So branch 2 times D not equal row Z, and then close the definition. So we'll get some text with enter text, but we'll assign whatever's entered to the variable Q. Q gets enter text, and then we can type in this is all character input. Now I should have put a space in front of the word character so that when we go out of this and display Q, that it would display with a space in between all and character. But I pressed enter, and the new line did not have any effect on the final character output that's stored in Q, but again, not adding the extra space did show up there. This next example, I'm going to it will not be a function definition. It's just going to show a mixed output statement. So n gets 5. And then we'll separate the different parts of our input with semicolons. So we'll do a character array here, note, colon, and then the iota symbol, and then we'll do a close quote, then a semicolon, and then n, and then another semicolon, and then a quote, the word is space, close quote, semicolon, and then iota n. So this is building up just a combination of essentially our character output plus some calculated values here, iota n. So we see the phrase then, note, iota 5 is, and then we see the calculation there for iota 5. Okay, so I'm going to go ahead and stop the episode at this point. We're going to be moving on from function definition to using mixed functions on just regular arrays and rectangular arrays in the next episode. So thank you for watching.